All right, guys, we are going to deal with some factor by grouping. Okay, that's the only way we know how to do some of these problems that have these four terms at this point. So we're going to jump straight to that. Up top here, I got a little bit of review, right? Find the GCF. So if you remember how to do that. So what's 24 and 18, both divisible by 6? Okay, and then r to the third and r squared, they both have at least two of them. So then you would divide it by that 6r squared and 6r squared. So if you know what you're doing with that, then you're in good shape. If you don't know what you're doing with that, then you might struggle a little bit this lesson. So here we go. Here's what happens. We're going to take the first two terms, and we're going to deal with them completely separate than the second two terms. So let me flip this out. I'll make those orange. Okay, could highlight. So 2x and 6x squared both have a GCF of 6 and 2 are both divisible by 2. X squared and x both have an x. So I'm going to divide that. I get 3x, and 2x divided by 2x is 1. Okay, and I'm going to leave a little space, and I'm going to write 3x minus 1. Why am I going to do that? Because these things have to match. Otherwise, factor by grouping is not an option. So as you take a look at the second half, 3xy and y both have what in common? Y, right? Other thing I'm going to point out is that sign is negative. It stays negative. So I'm going to only take out a positive y. Okay, so we're going to take out the part that's common to both halves. Now what I'm going to do is I'm going to take my two GCFs, these two right here, and I'm going to write them as a binomial, 2x plus y, and I'm going to write these that match one time because it would be 2x times this and y times that, and that's what we would get if we were to FOIL it back together. Okay, so that's how we do this. It's called factor by grouping. How do I check it? If you FOIL this, we should end up with what we started with. So it's pretty sweet that way. So we're going to look at the first two terms, the second two terms separately. We're looking for a GCF, pull it out. The binomial portions, what I have highlighted in blue here, they have to match. If they don't match, then we just can't do it this way, in which case I shouldn't have put it on here. All right. Yeah, we got one of those later on. That's all right. All right, now I'm going to give you worst case scenario in the next one here. So we get the first two terms, second two terms. Here we go, highlighter. 6 and 9, both divisible by 3. H to the fourth and h to the third, they both have at least 3 of them. So 6 divided by 3 is 2. And if I have 4 h's, I take out 3, I still have 1. 9 divided by 3 is 3. H cubed, we're going to get rid of all of them. I'm going to leave a little space. 2h plus 3, these have to match. So 12 and 18, well, I know they're both divisible by 3, but is that the greatest common factor? And here's the nice thing about dealing with it this way. I can say 12 divided by 2 is 6. 18 divided by 3 is 6. If those match, then this is the GCF. The only problem here is h squared and h, so it has to be 6h. Okay, the signs are already the same, right? These match, so I'm going to take out a positive. Remember, the GCFs go together, 3h cubed plus 6h, and then 2h plus 3. Okay, now remember I said I'm going to give you worst case scenario. What do you notice about 3 and 6? They're both divisible by 3. That means this problem to get started, this polynomial, had a GCF of the entire thing that I just completely overlooked. But there's nothing wrong at this point. It's just not complete. So I'm just going to take out the GCF one more time. So 3, and they both have an h. So I'll get h squared plus 2, and 2h plus 3 stays put the way it was. And that is my final answer. So if I multiply all this stuff together, FOIL, and then distribute another 3h, then I have the answer. Okay, so now we're kind of looking for that, but I don't think I did that again in these notes prepared for you today. So let's take a look. What's the factored form? First two terms, 8 and 16. Right? Don't go by 2, don't go by 8. They're both divisible, or by 4, they're both divisible by 8. T cubed and t squared, so they both have at least 2 of them. So that'll give me t plus 2. I need to get t plus 2 again. So my GCF of 5 and 10 is going to be 5. Okay, the sign was plus and it stays plus, so I can take out a positive. So 8t squared plus 5. Those are my GCFs. They go together, and t plus 2. There we go. All right, the next one, first two terms. Let's see, 20 and 8, both divisible by 2, but I think there's more. 4, right? 4, r cubed and r squared, so they both have at least 2, so I need 5r plus 2. I need to get 5r plus 2. Okay, so let me use this idea again, right? Sign stays the same, so I'm going to take out plus. 15 divided by 5 is 3. 6 divided by 2 is 3, so this must be a 3. 4r squared plus 3, that goes together, and I need a 5r plus 2. Okay, so hopefully by now you're seeing kind of the pattern to it. All right, so I left this one in here. In a different year, when we go in a different order, we might be able to do this. All we can do with this is a GCF, and then we'll deal with the rest of it later on. Okay, so let's see if you really have it down. Can I factor this one by grouping? So let's take a look. 6 and 2 are both divisible by 2, and I get q squared. So I'm going to get 3q plus 2q squared divided by 2q squared is 1. So 3q plus 1. All right, so I need that again. So 12 divided by 3 would be 4, right? But the GCF of 12 and 3 can only be 3, so this would have to be a 4. If these don't match, then my answer is no, right? They can't be factored by grouping. And the other part is we'd have to change the sign. It would mess up my signs. Okay, so this one is not, and my reasoning or explanation is I can't get the binomial pieces to match. If they don't match, we can't do it. All right, so let's see here. Now I see some of the signs starting to change. So let's focus in on that. X cubed and x squared. So x squared, I get an x minus 5. I need to get an x minus 5. Notice I already have a minus, so that's good. 2 and 10 are both divisible by 2. So that'll give me 10 divided by 5 is 2, so that works. Kind of full circle idea. And I don't want to change the sign because it's already negative. So there we go. So x squared plus 2 goes together, and x minus 5. Easy peasy, as they say. First two, 6 and 15, that's 3. Let's see, x, y, and an x. They both have an x. So 2y minus 15 divided by 3 is 5. I don't lose track what I'm doing. So I need a 2y minus 5, and it looks like I'm pretty close to it, except for there's an m in the way. So m is the GCF. I don't want to change that sign, so it's plus. GCFs go together. 3x plus m times 2y minus 5. Again, I can FOIL this, and I will end up right back at my answer, and that's what we're after. It's a factor by grouping. All right, finally, the one I was after all this time. Here we go. So I got xy and 4y. They both have a y, so what's left is x plus 4, and I'm going to divide by y. So I need to get an x plus 4. Well, there's one thing that I noticed right away. This is supposed to be a highlighter. Oh, that's awkward. My OneNote just shut down. Here, let's pause this. That was terrible timing. All right. So what were we saying? We're saying that, all right. So I need x plus 4. X plus 4. There it finally goes. Here we go. And what I want to notice is this sign right here needs to change. So what that tells me right away is my GCF has to be negative. All right, 3 and 12 are both divisible by 3, right? Because 3 divided by 1 is 3, 12 divided by 4 is 3. So this works, but this is the first time we had a sign changing GCF. So that's what we're looking for. Y minus 3 and x plus 4, and then we're in good shape. All right, so you can kind of notice the pattern of the signs. That tells you that something's up, right? I had plus, plus, minus, minus. Okay, versus in this one, I have plus, minus, plus, minus. So they're just both going to be negative, and we already did one of these. So let's take a look at this one. So 15 and 3 are both divisible by 3. I see an x and a z, so I can't do anything else with it. So 5x minus z. I need a 5x minus z. So what's the extra thing here? 5xy and yz. So they both have a y. And notice here, I don't want to change the sign, so plus y. So 3 plus y times 5x minus z will give me my answer. All right, so if you're comfortable with what we're doing, I think we're going to have evens out of here. For homework, if you're not sure, then just hold on to it, and we'll do those after some pair deck and some time for questions in class. All right, all right. There you go, Algebra 1, factor by grouping.